Hello guys, hope you are doing good. Welcome to the video session on black box testing. So today we are going to see about what is black box testing and what are the methods available in black box testing. So basically black box testing is used to test the functional specification of the software. The functional specification can be tested based on inputs and outputs of each and every component of the software. So this black box testing is also called as functional testing. Here what we are going to do means we are checking all the state, input and output of each and every component. Each and every component will have a defined input and an observed output. So now for each and every input we have to check the output which is an observed output that has to be compared with expected output. So while comparing the expected output and an obtained output, if there is any deviations in the output, then we can find any errors in the output. So for this we have three different methods available in black box testing. One is graph based testing, another one is equivalence partitioning, and third one is boundary value analysis. First let us see what is graph based testing. A graph will be constructed with the help of nodes and edges. So here our nodes are nothing but objects. So objects are nothing but your inputs and outputs. So how your input is converted into your expected output is the graph based testing. So your object 1 is input and object 2 is output, which is produced based on the input object 1, and object 3 is an output which is produced based on the input object 2. So here we are constructing our nodes as an objects. So already I said object is nothing but a data that is an input or output, and the link is nothing but the relationship between each and every data, that is input and output. So how your input is converted into output, that relationship is depicted in link. And we have another two notations called node weight and link weightage. So you can have a weightage for your node and also for your link. So your links can be a directed link or bidirectional link or parallel links. So here let us see, from object 1 to object 2 it is a directed graph. It is a one-way direction. So object 1 is an input and object 2 is an output. But the link between object 2 and object 3 are parallel links, and link between object 1 and object 3 is an unidirectional. So you can have both can be an input or output. So that can be depicted with the help of the graph based testing. So here from this what we are going to know means your input is converted into output. All your inputs are marked here as an object and your output is also marked as an object. From this you can get the cause and effect. So what are the causes and what are the effects in your component can be depicted here. And the second method is equivalence partitioning. So in this equivalence partitioning, your input data has been partitioned based on some conditions and test cases. Let us see. So the input data are divided into different partitions, that is called as derived. So your input data will be derived into partitions of data, and based on that partitions of data we will uncover some test cases. The test cases will give you n errors. So based on the test cases we will find different errors in your input. So the total number of test cases can be reduced based on the inputs. So your input are classified into different categories, and we are not going to write test cases for each and every input. A classification of input, for each and every classification we will write a test case. Let us have an input condition. So based on that input condition your equivalence classes will be produced. That is, equivalence classes is nothing but a set of valid and invalid states. So let us take this diagram for an example. The first level of partition is nothing but a valid input and invalid input. Your valid inputs are partitioned in one location and invalid inputs are partitioned in another location. And also after partitioning it you can subclasses it. For example, if you have a age as an input, for example, in your age we may have ranges from, like say, 25 to 50. If we have a ranges from 25 to 50, we can separate our input from less than 25 and greater than 50. So that can be partitioned here. For example, so let us take an example. Now we want to give an input as an integer input. For example, an integer n, it will be not maximum 99 and not less than minus 99. So that is why mentioned here. Your n value should be greater than minus 99 and less than 99. So for this input, we should have a classification, that is valid equivalence class and invalid equivalence class. And also we have another input that is a phone number. So basically your phone number is constructed with area code, prefix and suffix. So here we have a area code. So your area code will be from 200 to 999, and prefix is also 200 to 999, and suffix can be any 4 digit. So for this we have to write the valid equivalence and invalid equivalence. So let us take the first input. The first input is I already told that the range. Your number should not be less than 99 and it should not be greater than minus 99. So here we are having minus 99 to minus 10. That is a valid input. And minus 9 to minus 1. In a 2-digit number, it is minus 99 to minus 10. In a single digit number, minus 9 to minus 1. 0 is also in between the range, so it is also valid input. And in positive side, you will have 1 to 9 and 10 to 99. So these are the valid inputs. So let us check the invalid inputs for the same number. So less than minus 99, that is an invalid number. Greater than 99, that is also invalid number. And malformed numbers, like if I place a minus symbol after the number, instead of minus 12, if I give 12 minus, it is an invalid number. And also continuous numbers like 1, minus 2, minus 3. So it doesn't have any meaning. Like this type of numbers can be an malformed numbers, that is errored input. So these are all classified into errored input. And also this input is only an integer number. If I give a non-numeric string, like any other strings other than the integer, if I give any other input, it is an invalid input. And also another one condition is the empty value. You should not leave the input form as an empty. So these are all the invalid equivalence classes for the integer input. And also for the second example, the phone number. So various countries are following different type of phone number formats. Some countries may follow this type of number format, and some countries may follow this type, and some countries may be following this type. So these three types are the valid input for your phone number column. And your area number should not be less than 200 and it should not be greater than 999. So you have to ensure between 200 to 999. That is a valid input. Prefix and suffix, we have a 4-digit number. So that is a valid input. So what are the invalid classes for these inputs are? The invalid forms are, so we already mentioned the format for valid input. If there is any format other than these three format is considered as an invalid format. Let us take this. So here the 5 is a number that is continuously given without any hyphens or brackets. So then it will be considered as an invalid format. So because we already mentioned the formats for a valid input, and this type of brackets is also invalid. So your area code less than 200 or greater than 999 is also invalid. So area code with non-numeric characters. So if you have any non-numeric characters in your area code or prefix or suffix anywhere, it is not acceptable. And also empty values is also not accepted here. So like this, we have to construct a valid equivalence class and invalid equivalence class for each and every input of our component. So based on this, we will find out what are the valid inputs and what are the invalid inputs. For valid input, we will get an output. For invalid input also, we will get an output. So we can match the deviations. So if you give invalid input, your software should reply with an valid statement that your input is not valid. So for that we have to give an error message. For giving that error message, we have to classify the valid inputs and invalid inputs. So let us check the guidelines for defining the equivalence classes. If an input condition specifies a range, like example, your input range must be 1 to 10. Like this, if you give 1 to 10 as an input value, then your equivalence classes should be, there should be two equivalence classes. One is the value between 1 and 10, and another one is less than 1, and another one is greater than 10. So you will have a three equivalence classes. One is valid input and other two is the invalid input. So your valid input is between 1 to 10. Invalid input is less than 1 or greater than 10. Both are invalid condition. This is for a range. For example, if you have a specific value, for example, my value is a 250. 250 is an valid input. Any number which is less than 250 is invalid input, and any number which is greater than 250 is also invalid input. And the third guidelines is a member of a set. It means you will have a set of number as an input, various numbers, various type of numbers. We cannot predict, it will not belongs to a range or a single value, a multiple value. So let us take this set. Here we have minus 2.5, 7.3 and 8.4. These are the valid input for my component. But at the other case, you may have any other number than these three number is considered as an invalid input. So we have only two classes, valid input and invalid number. Other than these three numbers are called as invalid numbers. So in this case, we will have only two equivalence classes. And next, in your input, you may have a Boolean value. So true condition and false condition. So if your input will consider only true condition, then your equivalence class will have a true condition is a valid input and false condition is a invalid input. So you will have a two equivalence classes. So likewise, we have to construct the equivalence classes for each and every input for your component. Okay, let us go for the third method. The third method is nothing but boundary value analysis. It is nothing but we are checking the boundaries of the input. So here also we are considering only the input. So errors tend to occur at the boundaries. So like if you are using any arrays, so array will have a limitation. So your array will have a boundaries from 0th index to nth index. If you have any numbers other than that 0th index to nth index, it will be considered as an error. So that boundaries will be checked in the boundary value analysis. If your input condition will have a comma b, that is your number from a to b, any number which is less than a and greater than b will be considered as an invalid input. It is used to uncover internal hidden limits in your code. So guidelines for boundary value analysis most similar to your equivalence classes. If an input condition specifies a range will be from a to b. A value less than a and greater than b is considered as an invalid input. So let us check the value a and b as well as the value just above and just below a and b is a invalid condition. If an input condition specifies a number of values other than the range, if you have a set of values, number of values, any numbers not belong to the test cases, that is invalid input. The number of values are either a comma, if you specified a comma b, that a and b is the only valid input. Numbers other than a and b, that is maximum a and minimum, maximum of a maximum of b, minimum of a and minimum of b, both are considered as an invalid input. So here, if the internal data structure has been prescribed boundaries. For example, if you are using an array, I already told you that. So array will have a set of numbers. If you have a set of numbers in your data structure, then there will be a range from source to destination. That is a set of numbers. So that will create a boundary that is from starting number to ending number. So here let us take the same example what we are using for equivalence classes. So you should not have a number less than 99 and greater than 99 for a input. And also for phone number, your area code should be between 200 to 999, and prefix also between 200 to 999, and suffix of any 4 digits. So we have to write the boundary classes for these two inputs. So let us take so your boundary classes will be, so we are specified that minus 99 is the valid input and positive 99 is also a valid input. And here the minus 100, minus 99 and minus 98. So these are all the boundary ranges, boundaries for the input. Minus 10 and minus 9 is a in 2 digits it is a minus 10 and minus 9, and in a single digit values it is minus 1, 0 and 1, and positive number is 9, 10, and in positive side 98, 99, 100. So these are all the boundaries for your range of input. So likewise in the phone number also, in area code we are creating input up to 200. So we are getting input from 200 to 999. So your boundary values for 200 is 199 and 201. So upper boundary and lower boundary. So we have to check the upper boundary 201 and lower boundary 199. For area code also from 200 to 999. No? So for 999 your upper boundary will be 998 and lower boundary will be 1000. So for prefix also same condition. For each and every number we should check the upper boundary and lower boundary. For a single input we should check the upper boundary and lower boundary. Your suffix will have a 4 digit. So we are for 4 digit number the boundaries are on 3 digit number and 5 digit number. So these are the boundary classes, boundary cases for the input. So what is the advantage of going for these testers? So it doesn't possess the knowledge about the internal logic structure of the software. So we are not checking about the internal logic of the software, we are checking only the inputs and outputs. So what are the errors we are uncovering? So incorrect or missing functions, interface errors, errors in data structures, performance errors, initialization and termination errors. Like so in a range we are fixing 99 means we are checking 98 and also 100 both as a boundary values. And what is disadvantage? Independent path cannot be tested. For each and every input we are not checking the internal path for the internal data flow of the input. So that is not checked here. And logical decision, what are the inputs we are giving? So based on that input any logical decision may be taken. So your logical decision may have a true part and false part. We are not checking on what is a true part and what is false part. We are getting only the output. Based on the output only we are testing. And all loops and their boundaries, internal data structures cannot be validated. So a loop is nothing but a for loop or while loop. We are not checking with internal data structure and internal boundaries for the loops. So these are all the drawback for the boundary value based testing. Thank you.